right, good afternoon. I think I'm going to go ahead and get started. I'm Paul Mitchell. I'm president of the Indy Autonomous Challenge. And it's good to see some familiar faces here. I've been following us closely for the last few years. Indy Autonomous Challenge is an Indiana-based nonprofit that organizes autonomous racing competitions among university-affiliated teams from around the world to develop AI driver software that pilots our fleet of 10 world's fastest autonomous race cars. Since our launch in 2019, we've held 5 history-making race events at iconic tracks around the world, from our start at the Indianapolis Motor Speedway to our most recent competition at the F1 circuit in Monza, Italy. We've achieved more than 7,000 miles of high-speed autonomous testing, and we've set every autonomous speed record along the way. We do this not just for the thrill of having 2 race cars, 2 robots racing at 180 miles an hour, although my 10-year-old will tell you that's as good as reason as any. We're doing this because we've developed the IAC to be an innovation platform, furthering state-of-the-art technology, safety, and performance of autonomous vehicles. We're also doing it because we want to establish a global pool of top PhD and researcher talent that can advance AI driver capabilities. And thirdly, we're doing it to win hearts and minds of the general public by showing them that autonomous vehicles can operate with the skill and precision of top human race car drivers, so that someday that 10-year-old of mine will live in a world where high-speed autonomous mobility on highways will be much faster, more efficient, and most importantly, much, much safer than anything humans can achieve on their own. We are thrilled to be here sharing our news and our plans for this vision at CES 2024. It's great to be back at CES, hosting the Autonomous Challenge at CES at the Las Vegas Motor Speedway this Thursday. I'll share some more details with you in a bit. Over the years, we've made history at CES. In 2022, we ran the first ever head-to-head competition of autonomous race cars. We came back again last year, and we achieved a new record for world autonomous speed record on a racetrack when Team Polymove achieved 180 miles per hour. And now at CES 2024, we are unveiling our next generation of autonomous vehicle technology and showcasing its game-changing capabilities on the track. After setting these records over the last few years, our university team has found the limit of our first generation, what we call the AV21. So our engineers set out, working with a one-of-a-kind global network of industry partners, more than a dozen top industry partners from around the world, to develop this next generation vehicle platform, the IAC AV24. This new robot will unleash the full potential of our university team's AI drivers, allowing them to push limits that have not been attempted before by man or machine, and to do so in a way that will develop technology that eventually will save lives and dramatically speed up our forms of mobility. It's one thing to hear about it, for me to talk about it, but it's really something you have to see to believe. Let's have a look at the IAC. software providers to develop this state-of-the-art robotics race car. We wouldn't be here today if it wasn't for these industry partners. Companies like Bridgestone, Cisco, Continental, D-Space, Luminar, New Eagle, NI, VectorNav, and many others, many of which are in this room. It's their contributions of innovative hardware and software technology and their support of expert engineering that made the development of this AB24 platform possible. And we really want to give the thanks to them, because this vehicle is not just an IC race car. This is a marvel of technology innovation from the most cutting-edge technology, coded by the smartest, most capable AI software engineers in the world. Working together, we've evolved this robot to be smarter, faster, more capable, and IC, with this IC AB24, will be pushing new boundaries with several world's first new features that will usher in a new era of high-speed automation. I do want to point something out. This project was executed in record time. We went from CAD designs to 100-mile-an-hour test shakedowns a couple months ago at the Las Vegas Motor Speedway in 8 months. Now that is crazy fast, even for the motorsports industry. That is not possible, it would not be possible, without the approach that we take that includes open innovation, rapid prototyping processes, and sim-to-real test platforms that ISC has developed over the last 3 years, added in with the 7,000 miles of high-speed autonomous racing. We knew what the robot needed to do to get better, and we were able to execute in record time. Let's talk about some of the features on this new vehicle. There's too many for me to go over in this presentation, so there's a lot of information on the screen here. We have handouts that gives you what we call a hero card. If you don't have one, you can get one before you leave. It's important to understand that everything on this list goes into the development of the robot that sits inside the race car chassis. Let's talk about some really unique new features. We believe it's the first time, it's a world's first, of having true 360-degree, completely uninterrupted, long-range LiDAR vision. To do that, we used 4 Luminar Iris LiDARs. I see represented from Luminar here. They've been our partner providing LiDARs since the beginning. We've had 3 on the previous cars. This is a more powerful, longer-range product, and we're integrating 4, so we eliminated any blind spots for our race cars. We're using advanced 4D radar perception from Continental, the ARS 540 sensors. This is cutting-edge technology, much like the Luminar Iris, that you can find on the roads today in commercial deployments. They may not be putting 4 irises on a car yet, but they're putting irises on the cars, and they're putting Conti's radar on cars. We have state-of-the-art high-throughput computing platforms, the Altera from D-Space. We've actually had that product in the cars for over a year now. It was part of our initial step towards this evolution of having the world's most advanced autonomous vehicle. But we'll be matching that computing onboard the car with a high-fidelity digital twin provided by the simulation capabilities of D-Space. I'll talk a little bit more about that later in the presentation. One of the things that is really unique about this vehicle is that IEC custom engineered a drive-by-wire system. We did this in-house because we realized that using an off-the-shelf drive-by-wire system would be difficult when you're talking about the speed and the capabilities of these race cars. So we went out and we found actuators, and we found linear actuators. We actually separated the rear and front braking systems on these vehicles. And we're very proud of the work that was done in-house by our engineering team, led by John Singavi, to develop this really first-of-a-kind innovation. We also have the world's first automated race control. We've partnered with Morelli. Morelli is a company that provides race control technology for Formula One. Their technology, the transponder and race control, is in every Formula One vehicle. What we're doing with them is demonstrating that you can have automated race control. You can send flags to cars if they're not following the rules. You can slow a car down if it goes into the pits too quickly. This is exciting because it proves how you have a smart network that's supporting autonomous vehicles with smart infrastructure, but it also could unlock greater levels of safety in human-driven race cars, which is a passion that we have. We have a custom hardware in the loop system that's being developed by our partners at NI. We've improved the GPS GNSS with enhanced localization sensors from VectorNav, and we've created a modular design for this vehicle. The IC24 robotics system is modular, allowing for enhanced serviceability and integration into other high-speed vehicle platforms. As you can see here, essentially the chassis is the same, so we've not built a new race car. In fact, the race car that we've been running since 2021 is a well-known race car product. It's used in the Indy Next series. It's manufactured by Dallara. We have an engine from a company called Four Piston Racing. It's the same race car that the Indy Next series has been running since 2015. What's special about it is the robot inside of the car. So same chassis, new robot. That's what we're bringing to the market with the IC8024. And this new vehicle will be on display all week at our booth in the Las Vegas Convention Center West Hall, booth number 5901. I encourage you to check it out. We've got an incredibly innovative display that I think will be pretty eye-catching. If you want to see the vehicles up close and personal, of course, you got to come to the racetrack. And so we will have our Autonomous Challenge at CES 2024 that will be held from 3:30 to 6 p.m. at the Las Vegas Motor Speedway. All of you are invited, all members of the media are invited. You know, we've talked with members of the media in the past about the experience out there. This year we've made some adjustments in the schedule, we've made some adjustments in how you all will be engaged, how you can interact with the industry leaders that will be there, the university leaders that will be there, with the teams. I'm really excited for those of you, if you've been out there before, come again, join us, and have a wonderful time. One thing that we're going to do is we're going to be pushing the envelope of what autonomous vehicle technology can do that humans can't do. We're going to run these cars in dark, right? Because autonomous vehicles don't need daylight. The LiDAR, the radar, they can see at night. And why we do this, one, because it's really cool. But the second is that this is what people need to understand about autonomous technology. You know, it doesn't matter how good of a driver you are. At that twilight time when you're dealing with darkness, we know that human capabilities drop. We know that there's a lot of people that die unnecessarily because of night driving. And if autonomous vehicles can do something to improve that, that's a mission worth pursuing. While our AV24 robot will be advancing driving in the physical world, we are also thrilled to announce another innovation that we're rolling out in the virtual world. This year we are launching a deeper collaboration with a longtime partner of ours, an industry leader in this space, D-Space, who will be developing a first-of-its-kind, high-fidelity simulation and loop tool that can accommodate multiple AI drivers operating together. Actually, they could be operating from around the world via the cloud, racing each other in the simulation environment. IC and our university teams have long identified a technical gap in the access to a high-fidelity simulator that can support true head-to-head racing of multiple AI drivers, offering what we really need to be a true digital twin of our race cars and our racetracks. And we're incredibly thankful that D-Space has stepped up to offer to fill this gap with their revolutionary Simfera software in the loop product. I know they're going to be announcing this in a press release that's coming out that will talk more about this technology, and throughout the week, if you'd like to learn more about it, you can certainly come talk to us in our booth or visit D-Space in their booth at West Hall. Current IEC university teams will have access to this simulator starting in the spring to use to develop, test, and validate head-to-head racing scenarios before they put those updates, those AI driver updates, onto these world's fastest autonomous race cars, right? It's risky, it's very expensive when they wreck, they do wreck, in fact, they wreck a lot. And so universities want to sort out these changes as much as possible in the virtual world before testing in the real world. Additionally, this unlocks the potential for new university teams who want to join the IEC to be able to do so at an entry level using a lower fidelity version of the simulator to determine if the performance of their AI drivers is up to the challenge of being a part of the IEC before they decide to either purchase a race car or earn time on one of our race cars. This official IEC sim racing platform powered by DSpace will launch in the spring of 2024 with additional functionalities added throughout the year. We're thrilled to have DSpace in the room. I see Vivek. If you want to raise your hand, if any of you have questions about this amazing technology, maybe Vivek can meet with you after we're done. As we look forward to our schedule for 2024, I'm excited to announce today, for the first time in this room, that we're going to return to the historic Indianapolis Motor Speedway on September 6, 2024. It means a lot to us to have this homecoming. Back home, again at the IMS, if you're a Hoosier, if you know IMS, they sing this song Back Home Again in Indiana to get the race going. And that's really what this is all about. The IEC started as an idea in the state of Indiana together with the Indianapolis Motor Speedway, trying to bring back the history that this oldest iconic track in the world has provided, originally as a proving ground for the automotive industry, to prove out can tires work for 500 miles, can engines work for 500 miles. Now we know that can work. We know we can drive cars from Indianapolis to Chicago and beyond, and the tires are going to hold up, generally the engines are going to hold up. What we don't know is whether autonomous vehicles are going to be able to handle these harsher operating conditions of racing in close quarters, head-to-head, speeds at greater than 150 miles an hour. And so we're happy to be back in Indianapolis. This homecoming reflects Indiana's leadership in performance automation and its commitment to becoming a global destination for bold innovation. We're excited to continue our partnership with the Indiana Economic Development Corporation. They provided the first dollars in to get the Indy Autonomous Challenge started back in 2017, 2018. A couple $100,000. Say, hey, go look into this idea, see if this is real. We'll take this risk with you. We think it's an exciting opportunity to showcase things Indiana's known for. And they've stuck with us along the way. We're also excited to partner with Sports Tech HQ, another Indiana-based organization, as well as Applied Research Institute, to attract the best and brightest minds around the world, building an innovation ecosystem, yes, in high-speed automation, but also in other mobility solution areas that the state of Indiana is in, electric vehicles, hydrogen technology, advanced manufacturing, and a lot of others. I'd like to invite Executive Vice President for External Engagement from the IEC, Ms. Selena Scardina, to the stage to share a few words about the Innovation Hub that we're building in Indiana and what it means for IEC to be returning to the Indianapolis Motor Speedway.
Thank you, Paul. The Indiana Economic Development Corporation is proud to continue to support the Indy Autonomous Challenge in its third year at CES. We are thrilled for the return of IAC to the Indianapolis Motor Speedway later this year in September in Indiana. As the racing capital of the world, our state has always had a strong legacy in mobility leadership. We continue to solidify Indiana as a global hub for performance automation, and we are attracting the brightest minds from around the world to boldly innovate here. This partnership is a testament to the strong workforce, collaborative ecosystem, the abundance of resources that make Indiana the best place for future-focused industries like autonomous driving to thrive. Indiana is embracing the economy of the future through welcoming investments in our state in industries like AI, semiconductors, life sciences, electric vehicles, and advanced manufacturing. In fact, we've secured over $50 billion of committed capital investment in just the last 2 years. We are proud to be here at CES to celebrate the technical advances of the IAC, and we invite you to visit forthebold.com to learn more about Indiana's advances in mobility. Thank you, Paul.
Thank you, Selena. I should mention that the Indiana Economic Development Corporation is co-exhibiting with Indy Autonomous Challenge at our West Hall booth. That's booth number 5901, although I promise you, you're not going to miss it once you see the way this race car is displayed. It's going to be really, really cool. But they also, IDC is going to be in Eureka Park. This is the startup park at the CES. They'll have their own displays there, showcasing the startup ecosystem that in 2023, Forbes named the #1 state to start a business. I'm a born and raised Hoosier, so I'm always very proud of the work that we're doing in Indiana. To round out the year, let's talk about our schedule. Honestly, I don't think we could have found more iconic, legendary locations to showcase high-speed automation than our plan for 2024. I already mentioned our return to the Indianapolis Motor Speedway in September, but we'll also be partnering again with the Milan Monza Motor Show to take on the Temple of Speed, the F1 Monza circuit. We were there last year in June. We brought 6 cars. It was an incredible time trial competition. The winning team, Politecnica Milano, finished the lap in, I think, 2 minutes and 4 seconds. Now, that's not as fast as Max Verstappen, but it is actually a very good time for a skilled, let's say, gentleman race car driver. Not a Formula One driver, but certainly faster than I could do, or probably most people that are at the absolute pinnacle of motorsport. In addition to returning to Monza, we've got some other news to announce today. The IC will be extending our partnership with Goodwood. Goodwood has named us their inaugural partner for a new initiative that will be known as FOSTech at the Goodwood Festival of Speed. You can learn more about this by coming to our booth. There will be some videos showing what FOSTech is all about. And the Goodwood Festival of Speed is going to be held July 11th through the 14th, 2024. For those of you that may not be familiar with Goodwood, Goodwood is one of the longest running, most prestigious motorsports automotive showcase events held each year in the summer in the UK. And they have this famous thing called the hill climb, where cars of all different types, from Formula One cars to historic cars, climb up the hill as fast as they can. Last year we were invited to be part of Goodwood in what they call their Future Lab, where we had a car on display. But we actually, behind the scenes, most people didn't know this, we brought 3 teams with us, and we had some other cars there. And late at night, when they were setting up the course, we scanned the tracks, collecting terabytes worth of data to generate a digital map of the Goodwood Hill Climb so that our teams could train their AI drivers throughout the year to try to go back in 2024 and set an autonomous speed record going up the hill. It'll be a tough task. There's issues around connectivity, the hay barrels that run along the course. Got to figure out how to LiDAR use those things. There's a lot that has to be sorted out, but it'll be, I think, a thrilling opportunity. And we're really grateful to Goodwood for their partnership. There will be some Goodwood executives that'll be here at CES hanging around our booth that can talk about that. We're proud to push the boundaries of autonomous vehicle technology, fostering innovation and collaboration among industry, among universities, among government. These 3 historic venues reflect IEC's goals to win over the hearts and minds of the world regarding the promise of high-speed autonomous mobility and its potential to dramatically improve safety and efficiency of mobility for all. Next slide. CES is our marquee event. It's the world's largest innovation show. They've been a great partner of us from our unveiling the first Indy Autonomous Challenge race car during the virtual CES, and we love coming back each year. Join us throughout the week as we exhibit in West Hall, as we host insightful panel discussions on the importance of sim to real knowledge transfer. I know we've got some executives from DARPA in the room. They'll be part of that panel. There's a lot of great work that the U.S. government is doing in support of advancement of autonomy. And frankly, if it wasn't for the DARPA Grand Challenge, I don't know that any of us would be here having a conversation about autonomous vehicles. And so I know they're here and can answer questions that you may have at the end of this presentation. Also, come to West Hall, check out the exhibit there. And last but not least, please come to the Las Vegas Motor Speedway from 3:30 to 6 p.m. on Thursday for Racing After the Dark. We realize it's quite cold outside this year. We're bringing everybody inside. We're accommodating for that. The students are going to have to be outside. We bought some heaters so they can survive the winds. But yeah, it'll be a cool thing. And as I said, we're at least going to attempt. No promises. We can't guarantee anything with cutting edge technology, but we're going to attempt to run these cars in darkness at speeds over 100 miles an hour. I'll close today by thanking all of you for coming. I know there's a number of people in this room that have been following us from day one. We appreciate that. There's probably people in this room that this is your first exposure, your first time understanding what Indy Autonomous Challenge is. We hope it's compelling You know, most of our teams from 18 different universities around the world, and they represent all parts of the world. We have teams from Korea, we have teams from Europe, we have teams from Canada, and of course across the United States. But frankly, if you look at the makeup of these teams, they're from even many more countries than that, right? Because the students that make up the pipeline of talent that's working in AI, ML, and advancing automation is really a global challenge, and we are so proud to be a convener in that effort. Last, I want to say, in addition to the Indiana Economic Development Corporation, we have other organizations that will be in our booth showcasing their technology. That includes Applied Research Institute in partnership with DARPA Connect. It includes actually the Mach H2 Hydrogen Hub. There's a lot of talk about hydrogen technology and hydrogen hubs. We've got one that's in the Midwest that will be talking about their technology, and then CUI Car from Clemson University. It's so well known for developing prototype technology in the automotive space, and their fingerprints or paw prints, they like to say it, are all over the development of the Indy Autonomous Challenge. I'll stop now. I have a little bit of time for questions, if folks have questions. And if there's questions you have for me, I'll take a few from the podium, and then I can stay longer if necessary. Again, we also have Selena here from the IEDC, as Vivid from D-Space, and Alvaro from DARPA, in case you want perspective from industry, state government, federal government on this. We sometimes have our teams here, but they're all busy practicing, so there's nobody from any of the academic institutions. But if you want to talk with some of the teams, I'm sure we can arrange for that to happen.
Is the race format still the same?
The race format this year is the same. What's happening is that we built 4 AV24s. One of them is a show car in West Hall, and 3 of them are at the track. We've been shaking those new cars down since December. So some of the teams that typically compete opted to focus on helping IC in the development and shape down this next generation platform. So those 3 cars will not compete. They'll be there to exhibit, they'll be running the cars, they'll be showcasing their capabilities, but we did want to put them against the previous generation cars. So those teams that are running the first-gen car, the AV21, they're competing in the same format, 2 car at a time, head-to-head passing format. It's probably the last time, it will definitely be the last time that the AV21s run, and probably be the last time that we use this format. As we go forward with new vehicles, our expectation is that will allow us to go beyond the 2-car format.
To get to the race, you have a location that you can use for your lift and your own mass system that makes it a little easier.
You know, it's probably in my remarks, and I just glazed over it. I don't know if Allie planted that question. So this year, there are multiple ways to get to the race. You can drive yourself if you have access to a vehicle. The parking's free. You just drive in. You go under a tunnel. So you don't think that you need to park outside the track. You drive right into the center of the racetrack, and there'll be signs for parking. If you're taking Uber and Lyft, it's the easiest way to get dropped off and picked up for Uber or Lyft is, we should put up here, maybe in the know before you go, information that we have a QR code for, but it's to type in Dream Racing. Dream Racing is a company that operates out of the center of the track for people who want to drive exotic race cars, and it usually pops right up on Uber or on Lyft, and then they'll bring you straight in and drop you off, and from there it's easy to get to the media center. If you're members of the media, what we're doing this year is we're inviting all the media in to this main floor where we're probably about 350 people from across industry, academia, kind of all together. You know, please don't stick a microphone in front of everybody's face, but it's meant to create an opportunity for media to interact with industry, which is really what CES is all about in the racetrack.
Hi, Paul. Question, I've watched the competition over the last couple of years, and there have been a couple of clear leaders in Hollywood and Doom who've been sort of head and shoulders above the other teams. But from the beginning, it was always sort of pitched as an open source sort of competition, and while these kids are working on their PhDs, talk a little bit about how the competition's evolved to sort of bring the baseline up, the high water mark up for those teams that have struggled to get on the track the last couple of years.
So it's a good question. It's one that we've been thinking a lot about and talking to the teams a lot about. I mean, one of the things that's special about AI and the development of automation is once you solve for something, the AI driver doesn't forget. They don't suddenly get worse. They don't get older. They don't get tired. So, what that means is that if a team comes into the competition and they have a full stack autonomous driver capability that's superior, it tends to be a bit of a perpetual motion machine that it remains that way. And it is difficult for teams to catch up. Some of that is resources. These are, to put it in perspective, I don't know that people always appreciate when we say university teams, what we mean by that. Technical University of Munich runs a 15-person PhD team. Not part-time, full-time, 15 PhD students on Indy Autonomous Challenge. That's all they do. Polytechnico Milano runs a similar size team. And they're split in different domains of expertise. Our US institutions, some of them have pretty robust teams, but honestly, we can go into it, there's differences between how PhD students are funded, what they have to do in the United States versus Europe. And so what you've seen with the US teams to get better is they end up adding more institutions to their team. So one of the teams that does quite well is now being led by Berkeley. It has Carnegie Mellon, University of Hawaii, University of San Diego that make up that team, right? There's another team that's made up of MIT, University of Pittsburgh, University of Waterloo. So in some cases you have to pull expertise from different institutions. But we are thinking a lot about where we go with the driver development program. You have institutions that may be very good at one aspect of automation. They may be excellent at sensor fusion, or they may be excellent at some aspect of vehicle dynamics. But their PhD students or their faculty lead, is not an expert in all things automation. And if they're not good at every single one of them, then it's almost impossible in our competition to catch up or to win these races. So we are trying to figure out how we create more of an open, collaborative environment to do that and accelerate that development. And we'll have more to say about that in 2024, probably as we head into 2025. There's still a lot of progress being made by the teams that are catching up. Today I saw University of Virginia out there, playing back and forth, passing and overtaking together with two, Technical University of Munich, and University of Virginia is not yet qualified, so that's in the past 2 race events here. So already I think today they qualified, so that's a big leap for that institution. I'm hopeful that all of them will qualify before Thursday. Just one other comment I'll make on that is that, it's probably unrealistic to think that in the commercial autonomous vehicle industry, which has primarily focused on low-speed urban suburban robotaxi as the primary use case. I think we are seeing some movement towards over-the-road trucking with Aurora and some other companies, Too Simple and Kodiak and others that are working in that space. But most of the money, most of the investment has been on low-speed, when I say low-speed, relatively low-speed, urban suburban robotaxi. And I think it's difficult in the commercial realm for those companies to apply an open source approach. And we've seen that some of the collaboration in the development, the iterative development of AI, especially in generative AI, which is such a big topic coming into CES, we've seen that benefit greatly from sourcing improvements from a broad network versus one individual silo approach. And so IEC does believe that having a platform that can allow academic institutions and perhaps other contributors to make advancements in a particular area, test, validate in the sim environment, transfer it into our vehicles. These current vehicles, or now that this robot is chassis agnostic, we can put it into other form factor, other vehicles, and test that could really, again, unlock the potential for this iterative development of AI drivers. And once they get there, once they're on par or surpass top human race car drivers, even if it's just in certain aspects of driving, they're not going to be worse. Thanks for the question. I like getting into the technical stuff.
Hi. Last year, one of the points that you pointed at, that you mentioned, was that the forces on the computer technology and connectors, those are all areas of failure, and there's a lot of forces on it. And I wondered, over the past year, if you made any advances in that reliability area?
Yeah, so that was a big part of the design of the AV24 robot. I'll say it wasn't necessarily that we made a ton of innovations. The industry has improved a lot in connectors and packaging for autonomous vehicles. We now see most components using automotive Ethernet, which didn't even exist. We got started with IC. There's a lot more locking connectors, a lot more robust technology. We're not just sort of pulling from the off-the-shelf commercial computer server rack, maybe telecom industry. So we've seen a lot of improvements in that. The other thing we've tried to do is actually eliminate substantially the amount of wiring in the car. It still looks like it has a lot of wiring in it, but we've cut it probably in half. And we're trying to not run things through black boxes. So really the Altera Autobox that D-Space makes, that's the central, kind of brain of the car, as much as possible, we're trying to pull into that direct feeds from the perception systems and from the GPS systems. Our teams like it that way. They want to be able to have the raw data to use in their algorithm development. Not necessarily every auto company is going to want to do it that way, but the teams for this development want to do it that way. Even in the drive-by-wire system, the first gen car, I think we had like 3 different, kind of low-level computers that the information was traveling through. So, please do this brake pressure, or please do this steering position command from the AI driver, from the Autobox, and it bounced through like 3 different low-level computers before the actuator would turn. We got rid of all that. So there was more direct line of communication with the actuators, which allows for much faster response, in addition to the actuators being more capable just from their torque speeds and their response speeds, and the integration of combination of linear rotary actuators has helped a lot.
Follow-up question. Last year, I was lucky enough to be able to drive out on Friday and watch the races, which I encourage everybody here to try to do. It's really a lot of fun. But I spent a lot of time watching cars not moving, and it was frustrating, I know, for the teams. It was frustrating for the spectators. Did you ever do an analysis of why there were so many grounded cars last year?
Actually, the reality is the downtime last year wasn't all that different from the year before, from other race events. I think we made a big jump at Monza, and I don't want to say that it's going to get replicated each time, because each one of these events is different, and what's going on with the cars at any given moment is different. At Monza, I was really impressed. We had 6 teams there, and they were going out boom, 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 boom. We didn't have a single car get stranded on Monza, which boy, that was a risk because it's a gigantic track, and going and rescuing one is a lot longer than going out on an oval. So I do think we're getting better. You know, there's so many different things that can go wrong with getting started. Typically, once those cars are up and going and they're moving, they don't have as many issues. But it's making sure they're getting moving. I will say, you know, we did have some connectivity issues last year that were particularly frustrating on that day that hadn't been happening before, around the kind of Wi-Fi network that we use with cars. We don't use that approach any longer. So our hope is this year we have a lot better performance. Unfortunately, the weather right now is not cooperating. So even though there won't be any rain, it should be sunny. The track temperatures right now we're looking at probably 40 degrees, and really you need 50, 60 degree track temperatures for the tires to operate properly. You would never run human race car drivers head to head in a race with the track this cold. Cars will be okay to run, but they probably will not. We're not going to see a speed record because you need a much warmer track to do that.
Are you still running this week?
Yeah, they're out there today. They've been out there. We started running on Saturday, and we've had cars running each day. And we had cars running 120, 130 mile an hour laps today, and things are looking good for tonight. But we'll see where they are when they get there. You know, I think it's important to understand that there is a motorsports competition element to what Indy Autonomous Challenge does. But we have said from the beginning, and nothing's changed, this is not we're not trying to replicate Formula One, IndyCar. I was joking around with somebody. I said, you know, our competition is probably much closer to what you would have seen at the Indy 500 in the 1920s and 1930s. You know, there are a lot of cars that didn't finish the Indy 500, right? There are a lot of cars that didn't get started because at that point in time, it was about the automotive industry trying to prove things out that hadn't been done before, and that's hard to do. Eventually, motorsports changed and became a product where let's put out a spec car or a car that's developed where we know it's going to work pretty much every time. It just becomes the competition among the drivers. We're almost back to the future again, saying like, if we're going to test these things, we need to test them in these high-stress environments. What I will tell you is that our cars work and achieve results much faster than if you just had a one-off project in a lab without anybody saying, go now and perform. That competition element is what keeps these student teams working till 1 in the morning, showing up at 7 in the morning, you know, trying to figure out every possible problem. And I think part of that is that's the kind of iterative problem-solving environment that you need for this industry to advance. Okay, I think with that, getting the sign, we probably want to wrap this up. I'll be around for a moment if you want to ask any questions on the side. Again, all of you are invited to come to Indy Autonomous Challenge. We would appreciate it if you sign up with Allie, send her your contact information, let her know you intend to come. Ideally, stop by our booth and we'll give you a wristband. As long as you have a media credential, you're probably going to get let in without the wristband. But if you want to be, you know, a good rule follower, go to the booth, tell them your media, planning to go to the thing, get a wristband, get your name. Thank you very much. Appreciate it.